Welcome to this video on the topic of vectors. In this lesson, we're going to learn how to calculate the angle between two vectors in space. The angle between two vectors may be found by using the following formula. The cosine theta, so angle theta, is equal to the dot product of vectors u and v all over the product of the magnitude of vectors u and vectors v. Observing what this looks like as a diagram, we may have two vectors, vector u, vector v. Now what we're looking at is the angle between the two vectors. So the angle could be here, or it could be here. Notice that in both instances, we have different angles being drawn. The first angle we look at is this angle here. This is the acute angle. Acute because it's the smaller of the two. The other angle that we potentially could have for theta is the obtuse one. Observing the relationship here, we see that the sum of the acute and the obtuse angles will be 180 degrees, or in other words, it's a supplementary relationship. Now when we're applying this formula here, we're always going to get the angle that is formed between the tails of the two vectors. However, suppose we want to force it to be the acute angle. To force the output of this equation over here to always reveal the acute angle, we can simply apply the modulus to the numerator of the fraction. We typically do this if the question asks what is the acute angle or what is the obtuse angle. So we can force the acute angle by putting the numerator of the fraction in the modulus symbol, so make it always positive. Alright, let's have a look at some application now. We're going to do two examples. The first one being, find the angle between vectors u and v. To do this, we simply state our formula for finding the angle. That is, cosine theta is equal to u dot v upstairs, then downstairs we're going to take the modulus and product of u v. Keying this in, I'm going to say just like shown. Now I could go through the manual calculation for the numerator and the denominator, but it's a little bit tedious, so instead what I choose to do is I choose to use my technology. So I say up we come to the calculator, and what I'm going to do is I'm going to input this into my calculator. I go into run matrix mode. I'm now going to choose to put my vectors into the mapvec form. So I go across and I make sure I'm in the vec mode. Now I go options, mapvec, and now I go across. I'm using the vector features here. I do a fraction. Then I'm going to go vec a dot product, comma, vec b, close it off. Next, I have to do the magnitude of these two. So I'm going to go across, I'll go norm, F6 again to get back, vec a, close it off, multiply, vec b, close it off, execute. And here's my result. Now I might be tempted to just throw this down, but remember this is the cosine theta over here, and more so my calculator is also set to radians. Okay, I might be tempted to leave it here, but what I'm going to do is I'm going to find the angle itself and I'm going to force it into degrees, because typically speaking we work in degrees when we're doing these sort of problems. So I bring my calculator back up. I'm going to take the inverse cosine of my answer. So I'm now in radians, 1.004 radians, and I want to force it into degrees. So I can either change the settings in my calculator. I go shift menu and I can change from radians to degrees, but I don't like doing that with the course I'm studying. Instead, I always want to work in radians. So I go back, and instead, what I'm going to do is I'm going to get my answer. I'm going to multiply it by 180, and then I'm going to divide it by pi. So I just do the conversion. This gives me 57.53 degrees. This was to 2 decimal places. And because I've got that calculation there, I don't actually need that. I can choose to leave this line out and just represent it as this. So the way in which I choose to do this is I start off with the manual calculation, and then I work my way down by putting it in the calculator, and then I make sure that, because I'm working in radians, I make sure to do the conversion back to degrees. Okay, now for those who are watching carefully, you would have noticed there's a feature in the calculator to do this automatically for us. What we can do is we can go exit a few times, and then we can go options, map vec, across, and you see that there's the angle function here. We can simply put the vectors through the angle function, and out comes our result. And again, we simply do the conversion. So shift answer, multiply it by 180, divide it by pi. And you can see that it's a more straightforward way of calculating. However, having said that, you still need to know how to apply this formula here. But if it's all in numerical form, just like this question was here, it is better to simply just throw it in the calculator like that because you're less error prone. Okay, next example, it is find the acute angle between vectors A and vector B. Now again, I know how to do this. It will be the cosine theta of, as shown on the right here. Next, let's key this in our calculator. We will clear the memory, map vec, say goodbye to the vectors and put in the new ones. Okay, we go option, we're going to go map vec, we go across to find our angle, vec, angle A, vector A, vec, vector B, and out it comes. So our cosine of theta is 2.41. Now we need to, this is in radians, so we need to do the conversion. So I go shift, answer, times it by 180, divide it by pi. And here's our angle here. So our theta is 138.366. So this has returned the obtuse angle. Now remember, the question is asking for the acute angle. And this really showcases the limitation of the angle function here. It's going to either give you the acute or the obtuse. It doesn't really give you a choice. But what we can do is we can force this. The way in which we can force it is we can throw the absolute symbol up here to show that we're going for the acute angle. And then remember, the acute and the obtuse angles are supplementary to one another. In other words, they sum to 180 degrees. So the way in which we can get around this and force this implementation here is we can go back to our calculator. We can go 180, subtract the answer, and out comes the acute angle. So it's 41.63 degrees. Remember, you need to add the modulus symbol to the numerator over here, because if you don't, and you evaluate this, theta will not be 41.63 degrees, rather it will be the obtuse angle. So to show that it's mathematically consistent and correct, you need to put the modulus symbol up here to show that this actually equals this. And this is how we can find the acute angle. So we may choose to use technology to aid us along the way. So in summary, what we had a look at in this lesson was how we can find the angle between two vectors in space. We discovered that this formula over here can be applied to find the angle. However, looking at the diagram, there's going to be two results that we could expect to come out of this formula here. One revealing the acute angle, the other being the obtuse. If we choose to put the numerator in the modulus up here, then we always force the acute angle. And if we always force the acute angle, then we have a means of also forcing the obtuse angle if we want to. After this, we had a look at an example where we found that it's quite a long process to do it if you do it manually, so it's always better off if it's numerical to just throw it in the calculator. Remembering that our calculators are most likely going to be in radians, so we need to do a conversion once we've done the formula over here. And also remember that you need to apply the inverse cosine if you're doing it like here. In the second example, we had a look at the case where we were forcing the acute angle, in which instance we need to ensure that we're throwing the modulus symbol up in the numerator here. Otherwise it could give us the obtuse angle, and if we simply state what the acute angle is when it's going to give us the obtuse, then technically we're not showing our working out properly.